Okay. Welcome to my talk about Kotlin, but probably more importantly, Java. First of all, let's make the most important question clear. Who is Kotlin developer? Okay. Who is Java developer? Fine. Okay, so yeah, thanks. In case I say nasty words about Kotlin, then I hope the Java developers will defend me. Thank you very much. My name is Jaroslav Tulach, and for a long time I was doing something with Java and something in the Java ecosystem, but things changed. And since April, I'm working for a company called Enzo, and we are developing first visual textual programming language on top of JVM. So I still code in Java, but currently I also have more functional perspective. Well, being functional is not bad at all. In the middle of the 90s at university, where I discovered a programming language called Concurrent Clean, something like Haskell, and I felt amazed, and I always wanted to do something with functional programming. But then we needed to write a student project. And that student project turned into something that lasted way longer. It turned into NetBeans. So I'm also NetBeans founder and initial architect. And in case you are interested in NetBeans, then I'd like to let you know that NetBeans is still alive, in spite of not having as much support from Oracle as it used to be. But right now we are Apache Software Foundation project, and we are doing releases every 3 months, so the project is still evolving. Anyway, based on my experience of designing NetBeans, I got a feeling I know how to design an API, design a framework. And I sit down and I wrote a book about it. So that's what I do when I'm not working at the conferences. I found startups, I write books, and sometimes I also write virtual machines. So I wrote a back-to-browser virtual machine, which is capable to take Java bytecode and transpile it into JavaScript, so it can run in JavaScript. I'll do a bit of promo later in the talk. And based on the book and based on this virtual machine, I got an offer to join Oracle Labs. And for the last 7 years, I was working on a GraalVM, which is the fastest Java virtual machine. And not only Java, but also polyglot virtual machine. And yeah, as I mentioned, for the last 4 months, I'm implementing a programming language called Enzo, but it also loves Java. So the references about Enzo will be hopefully relevant in the context of a JVM conference. Okay, so the purpose of this talk is to actually compare Kotlin and compare Java and bring to your attention things where Java is not as good as it should, and maybe even think about what should happen to make Java better. So here are few things that I found really great on Kotlin. Basically, I don't know, 5 years ago or something like that, I helped to design an API for model view model framework for writing front-end applications in Kotlin. And yeah, it was a really interesting experience. There on the right, we can see the code that is using that API. And the things that I like really much on Kotlin are extension functions, extension methods. So basically, yeah, we all know Java standard libraries, right? So there is Java lang string class, and this class contains support for working with regular expressions. So for example, there is a method split that takes as a parameter a string representing regular expression. And in order to implement functionality of this split method, it needs to call into Java util regex expression, create a pattern, do all the regular expression processing, and return back. And of course, the Java util regex package depends on Java lang package. So we basically have a vicious circle. One package depends on another, and I call that object-oriented spaghetti design. Because sometimes you want to reach a small runtime, small Java. For example, in JDK 9, when the JDK was modularized. But the smallest part in there is called Java base. And of course, it contains Java lang package, as well as the regular expression package, because separating them would be too hard. However, if you are in Kotlin, and you want to add function split on string, which is using regular expressions, you can do it from the Java util regex package. So basically, the package can add a method to some class from Java lang string. And this is all just compile time thing. It does not add the method there in the runtime, in the bytecode. But for the user, it looks like the method is there. And basically, the usage is the same as we are currently using string.split in Java. Just there is the vicious circle between those two packages is broken. Java lang package does not depend on the regular expression, would not depend on the regular expressions, just that package would virtually insert extension function into the string. So this is fantastic thing and helps modularity. I wish Java had it. The other thing, which I like quite a lot, are delegated properties. And that basically allows you to define properties in some special way and do something when the object is created. So here is an example. It's used here many times. So this is a property called description, and it's designed as observable, by observable, which does some magic. And there is also by observable list, by computed, by action. And by using this by keyword and specification of the type of the property, you can do magic. Because then each of these properties actually starts to behave slightly differently. And in spite of that, the usage is quite natural, at least for Kotlin developers. The next thing that is amazing are reified type parameters. So basically, Java developers are well aware of type erasure. So if you create new hash map with for string and integer types, in the runtime, if you get an instance of such a hash map, you cannot find out what are the parameter types because they have been erased. This is useful sometimes and sometimes problematic. The typical way around that in Java APIs is to add each method a new parameter of type Java lang class. And that parameter will actually give you a reference. You can store it in hash map. If we had identifiable hash map that also holds the key type and the value type and returns a class, then we actually could, during runtime, find out what are the right types of the keys and values. But that requires the extra parameter somewhere, and the usage is problematic. Well, Kotlin improved that fantastically by reified type parameters. So you can actually create a function and tell there that you want to know the type parameters, and you want a handle for those type parameters, and then store them somewhere and keep them. And the whole usage seems much more simple. So that's another thing that is really nice on Kotlin. And last thing, and probably the most important, well, at least for DevOps guys like me, is that the language syntax is actually part of your build script. If you are using Java, then the language syntax you get depends on the JDK that you use. But that's not the case with Kotlin. With Kotlin, you basically specify the version of Kotlin compiler in your Maven POM file or in your Gradle script, and that version of the compiler also specifies the language features that you can use. Doing that in Java is not easy and not done, usually not done at all. But that means that in order to build a project, you actually need to find out the right JDK. Because if you have a JDK which is too old, it may not support the language features that you need. And if you have a JDK which is too new, it may already drop the target support for target bytecodes. So basically, we are in flux in Java, and we are used to that. That's quite surprising. Okay, so enough of talking about the benefits of Kotlin, and let me demonstrate what I have done with the API. So basically, the goal of this demo is to demonstrate that I can speak a bit of Kotlin. But probably it's not that fancy or that hard example. So this is the model view model framework that allows me to define an observable description, a list of to-dos, and then somewhere in HTML web page, I can actually reference these properties, observable properties, and render them. So basically, I can render repeat this sequence of HTML for each element in the to-do list, and then draw the data. And what I can do, and this is basically the example showing that I can write the virtual machine. So basically, this is a Kotlin compiled into jar file, then transpiled into JavaScript running in a browser. But basically, this is what the sample does. You can put there some text and add it into the to-do. Okay. So back to here. Basically, relatively simple code, easy to use for end user, using quite a lot of magic behind the scene with the by properties. That's Kotlin. And yeah, and actually another thing I should mention is the build script. So in the build script, what you usually do is you specify a Kotlin version. So this basically fixes the version of your compiler, downloads it from the Maven Central, and uses the right version to compile your code. And if you want, you can even target old JDKs. Try it in Java. Like if you want to use latest Java features and target JDK 8, well, what do you do? Okay, so I warn you, this talk is about how beautiful Java is, not how beautiful Kotlin is. So now the slides about why Kotlin is bad. Well, do you remember the lawsuit between Oracle and Google? Yeah? Oracle was suing Google for stealing Java in Android. And, well, of course, while I was Oracle developer, I could not talk about it. But now I have the freedom to finally say what I think. So first of all, should Oracle win, it would be a huge damage for open source software, because it's normal in our industry that someone re-implements some API. On Linux, we have a Wine emulator, which emulates Windows API. And even history of PCs started by Dell, I think, copying the BIOS of IBM PC and basically creating a whole new industry of personal computers. So if this would not be possible, probably the world will be too tight. So, but explaining this to judges and the guys that are sitting there as well, the jury, may not be easy. So actually, Google tried a lot. Joshua Bloch was going to conferences talking about how important API is and that it has to be copied and re-implementation has to be allowed. But that was not all. Google actually did quite a clever thing. It combined with JetBrains and convinced JetBrains to create a new language that will show proof that Java is not necessary. And that language is Kotlin. So Kotlin is nothing else than just an evidence in the lawsuit between Oracle and Google, and it has only this purpose. I have to say that for being an evidence, Kotlin is quite a good thing, good language. Sometimes it feels like pejsek s kočičkou vařili dort, when you actually mix all the goodies and put them together, but it holds. It's not bad language, and as we have seen, it is quite powerful. But for a while, I always thought, oh yeah, another JVM language, Groovy, Scala, Kotlin. But then at one Google I/O conference, Google actually announced that Kotlin is going to be the supported language for Android. And at that moment, I realized that the plan behind Kotlin was always to be an evidence helping Google to win the lawsuit. So that's the historical view. But let's take a look at from another perspective. I mentioned that I pretend to be an API architect and designer of frameworks. And one of the things when you design a library, which is quite important, is to keep backward compatibility. And in the case of JVM, that usually means binary backward compatibility. So you need to understand how the bytecode and class files are structured. And you need to understand how your language compiles into that class file. Even in case of Java, it's not one-to-one mapping. We mentioned the erasure of types. Then there are things with overloaded methods, return types, and things that you might surprise you. But the question is, do you know what your Kotlin compiler does? How its abstract binary interface, the Java bytecode, looks like that is generated? So I actually know, because we are using a tool, a testing tool called SIGTest, or NetBeans API test. And it allows us to snapshot an API and actually look at the bytecode, something like Java P, but also compare whether changes that you do to your code are still compatible or not. And, well, as the diff shows, there is a lot of debris put into the classes generated by Kotlin. The other thing that surprised me is the usage of internal. So sometimes you can say something is internal, but that doesn't mean package private. That actually, even internal things in Kotlin may be public. And, well, that was surprising. So these things just are problematic. And an API designer needs to be aware of that. I actually discussed that with Andrzej Grzesik, and I think he said something like, yeah, that would be good language to implement the functionality, but still then you need to create the facade in Java, so you know that the interfaces are clean. Well, come on. In such case, it's easier to write everything in Java. There's not a point in being such polyglot. That's maybe too much polyglot. Another thing is that because Kotlin is the evidence, they actually tried to avoid usage of certain Java packages. So rather than using Java util list in Kotlin or Java util arrays, there are special Kotlin packages to prove that Android is not Java only or is more Java independent. Well, but that also means that whenever you write an application in Kotlin, you need to carry these additional packages with you. You need additional runtime libraries. And writing Kotlin without these libraries is probably impossible. At least I don't know how to do it. Last but not least is annotation processing. The last time I tried, the annotation processing in Kotlin felt like an ad hoc things that you need to turn on. I heard that things got better, but still, I would say that annotation processing is not first-class citizen in Kotlin, while many Java libraries actually rely on annotation processing. So in case, for example, you want to write truffle libraries for basically implement your own language for GraalVM, you are using annotation processors a lot. And doing that in different language than Java is usually complicated. Okay, so here I'll skip this demo and continue. So what we have discussed. Kotlin has unclear ABA. Kotlin is an evidence, but the worst thing is there is only a single editor that you can use to code Kotlin. I guess I don't need to ask, is there, yeah, I can ask the negative question. Is there someone who is not using IntelliJ for development? Okay, so guys, I assume that none of you is actually a Kotlin developer because you cannot code Kotlin without IntelliJ. Well, I know only one other language which requires the only IDE for coding, and that's Visual Basic. So, dear Kotlin users, you are on the level of Visual Basic. It's just like, well, no way. I can, of course, open the Kotlin file in NetBeans and do some modifications, but the proper support is not there. And surprising is that actually it was there. JetBrains donated plugin for NetBeans in 2013 or 13 maybe, and also for Eclipse. But that was at the beginning when the importance of the evidence was really like important to be the right evidence. But then support for all the IDEs got abandoned. So, well, if you are a happy IntelliJ user, you can try Kotlin, but yeah, I cannot. For historical reasons. And actually, I believe it's not even necessary because Java can be as good as Kotlin or almost as good. Yep, so the rest of the talk is about Fregal. Fregal is a fantastic project that I just love because you have seen, if you were at the keynote, you could see how great the latest Java is. The features of records and decomposition, that's just amazing. But then I also saw the poll, and most of you is still on JDK 8, right? So, yeah, it's great, and Java is perfect, but if I cannot use it, then, yeah, that's a problem. Well, Fregal is a project that allows you to actually code in the latest Java syntax and compile for JDK 8. So basically you get the latest syntax with text blocks, pattern matching, enhanced instance of. And then it runs on every JDK from JDK 8+. And actually, it's not a new language. The language that Fregal project supports is Java, Java 19. So it's a standard language that it's not something invented somewhere, but it is a standard language designed by Oracle, Red Hat, and other contributors to the OpenJDK project. And of course, not everything is perfect. Certain things are still missing, for example, extension methods. But sometimes you don't need them. If you take a different approach in Java, for example, use more annotation processing, you can actually achieve almost the same experience as with Kotlin, just done slightly differently. So yeah, what I'd like to propose is that everyone should adopt latest Java 19 features. And if you need to stick to older JDK, consider Fergal, because then you will be able to actually enjoy your programming time and still run on the JDK you have to. Let's do a demo. Okay. Let's try. So I will create a new Maven project. GeeCON demo. Okay, so generating a Maven project. I can probably delete this one. I can delete this. So here we have an example of modern Java. And sorry, I'm supposed to make it bigger, right? So here we have an example of modern Java. However, it actually compiles and runs on JDK 8. So if I take a look at the POM, there is a definition or special section defining that the Maven compiler plugin should use a Fergal compiler plugin for Maven. And then what this system allows is to specify that you want to use source 19 and target 1.8, and even with enable preview. So all the features of Java should be available. Let's try it. So first of all, what we are using is record. We are using text blocks, and we are using the var keyword. I will run this file. And what's the output? The output is that it runs on GraalVM, which I'm not sure what is the right version. So let me switch the project, compile and run on JDK 1.8. So now run it again. Let's make it bigger. So now we are actually running on JDK 8. And we are printing some results using text blocks. So this is basically what the Fergal plugin gives you. It gives you the latest Java syntax in the JDK 8. Let's try a few things. So instead of var, let's do object. And now, of course, this world does not have a message, because originally the type of this variable was hello, automatically deduced. But what we can do is to do instance of hello age, and now we have basically defined new variable age, which is of type age, of type hello, and we can call the message. Well, we can also do other things. So for example, we can use switch expressions. And yeah, we can do case hello. And here we can also access the message method defined here on line 5. We need to provide some default. If we, let's try to verify that everything works, the message printed should basically be the same. So yeah, it is. What we can do is we don't need to call this message method. We can actually compose the message ourselves. So from age.who, say h.message, MSG. Okay, so now if I run it, well, the message will be from world, say hello. And and we can also do a deconstruction of the pattern. So I can do hello m var w, and here instead of calling the method, I can use w and m, and the result shall be the same as well. Okay. So just as a recapitulation, what you get: access to var, keyword, text blocks, switch expressions, records, and pattern matching. And that just makes your Java more cute. And sometimes, as I mentioned, Kotlin still offers better functionality. For example, the by keyword that allows you to define intricate properties. But turns out that you can actually do the same thing with in Java with annotation processors. So here is, if you remember the example with to-dos. Let's first take a look at the Kotlin version. Here. So it defines these properties, this computed property, and this action. And the same example can actually be written with Java, and some of the, let me make it bigger, sorry. And some of the JavaFX, I call it light APIs, so basically defining just certain properties. And this is, basically, this feels like a Java code, like a standard JavaFX code. And the magic of the registration, because we still need to somehow, the by keyword in the Kotlin basically registers for this instance, registers the properties and exposes them to the HTML page. And this is actually done by this superclass, which is generated. So this class actually creates some bean info descriptor and registers all the properties and all the methods that represent actions there. But this class is basically automatically generated by annotation processor, which is associated with this annotation. So if I actually say, okay, my super demo, then for a while the class was not available, but now it has been generated, so I can jump there, and all this code is basically automatically generated. So this basically shows that even such complicated thing like the by construct in Kotlin is approachable or achievable when writing a standard Java library. So stick with Java 19. Oops. And now I'd like to mention that, return back basically to the functional topic of Enzo language. Because in the Enzo project, when I joined, 60% of the code were written in Scala. And I don't like Scala that much. And I wanted to replace it with Java, but I could not replace it with classical Java from JDK 11, because a lot of the code that we need to do in the Enzo language interpreter is actually using switch expressions, which are natural in Scala, but were missing in Java. So in order to lower the amount of usage of Scala in the Enzo project, I actually needed to introduce Frgal project into our development. So Enzo is developed in the Java 19 syntax, with the switch expressions and is compiled by Fregal. And it works great. So let me show you how such a code that we maintain looks like. So this is basically a conversion of some abstract syntax tree into IR. And it is basically full of switch and case statements. So there is some tree of representing a source, and then we need to do conversions. And each there is a lot of subclasses of the tree class. One representing block body, another representing documentation, for example, and so on. And at the end, it looks like that there is a lot of nested invocations when we are basically using case, switch, and yield all over. And yeah, basically this was the look of the original Scala code. But with modern Java, we can do the same, and we can stay less polyglot, and code in Java, which I like. Yep. So I hope you actually could, or Fregal could actually give you a chance to use latest Java in your own project as well. It's easy to try. Just go to fregal.org and yeah, follow the tutorial. So basically, here there is a snippet that you need to put into Maven POM XML in order to enable Fregal, and here is a snippet that you can use with Gradle. You can also use Fregal from command line. If you want, or integrate it into your own build system. We had to do it in Enzo because Enzo is built with SBT. But even that is possible. So that's basically all I wanted to show you, and I'm ready to take your questions. They should be on Slido, so let's switch to Slido. Question. How fun debugging a code compiled with Fregal is? That's a great question, and it asks for a demo, right? Because actually, yeah, it's normal. It's just like debugging Java. So this is M, okay? What I can put there a breakpoint, and I can debug the file. So it compiles into a bytecode. And inside of bytecode, you actually have a special section which provides a mapping between instructions in the bytecode and lines in the source code. And, well, it's Java, so the mapping is basically okay. If I step into, I get into the hello constructor. If I step over, I get here. I step into the hello world, and that's basically it. It works like Java. So debugging is without any issues. And will probably work even in your favorite IDE. Fregal sounds like a useless project that will only delay adoption of new JDKs. Bumping Java in a POM file is a 5-minute job. Why not just update the JDK? Well, this is what the JDK team says all the time, right? So can anyone explain why half of you is still sticking with JDK 8? Yeah, because bumping a version of JDK is not that easy. It's a nice joke. it's not about whether, if you can update JDK, then indeed do. There is not a reason not to do so. But if you cannot update JDK and you want a better programming language, then don't try Kotlin. Just try Fregal and stick with Java. Because you can get a better programming language and still stick with your runtime. And this is basically what I got inspired by Kotlin, because Kotlin does this. Kotlin version of the compiler is specified in the POM file. And you can update it. The last time I tried it 5 years ago, it was Kotlin 1.3, and then I could bump into 1.7 just in the POM file, and it's still compiled into JDK 8. So this is what other languages do. Scala does that as well. So why Java could not do it? I don't get it, and I want it, actually. So that's the reason I'm talking about Fregal and trying to promote it. How is the compilation time affected on larger projects when using Fregal? I love the name. I love the name too. Well, for those who don't speak Czech, Fregal is a cake from the border between Czech and Slovakia. Okay, so how is the compilation time affected? I was actually afraid that Fregal would slow things down. But recently, I actually tried to compile NetBeans with Fregal, and the result was negligible. Basically, compiling NetBeans with regular JDK Java was something like 5 minutes 20, and compiling it with Fregal was 5 minutes 30. And meanwhile, I was doing some other things, so probably it's the same. IDE support for Fregal. Well, yeah, I have to recommend the best IDE for developing modern Java features. It's NetBeans, of course. The reason for that is that NetBeans actually contains in itself Java C. So whenever you work in the text editor, you are actually calling into Java C. That's not what the other IDEs do. Their IDEs basically implement their own Java parser, and that means there may be bugs. So sometimes you see an error in the editor, and when you compile on a command line, everything is okay, or the opposite, when you are not using NetBeans. But with NetBeans, what you get is WYSIWYG experience. Really, what you see in the editor, if you see the error in editor, you will see it on the command line as well, because the compiler is exactly the same and has the same error messages, same warnings, same behavior. But otherwise, I think it's just about your IDE being able to understand Java 19. So in the speaker room, I heard one speaker an hour ago saying, well, I need to download new IntelliJ because it was buggy supporting something in JDK 19. So he needed to download new version. So yeah, the support is there. Your experience may vary. With NetBeans, you would get a WYSIWYG experience. How major are the performance hits when running the code compiled by Fregal? Well, most of the features that Java offers are syntactic sugar thing. Instance of, well, that's a syntactic sugar. It does not change the bytecode. Switch, well, it's a syntactic sugar as well. It doesn't change the bytecode. It looks quite similar. Text block? Text block, well, text blocks are actually, the strings are stored in constant pool, so it's no difference. If you concatenate the strings, the compiler will do the same thing as when you use a text block. There are some differences, but not because of Fregal, but because of the JDK support. So for example, in JDK 11, if you concatenate strings, it is done by invoke dynamic instruction. So the code on JDK 11 is different than it used to be on JDK 8. But Fregal, if you basically say, okay, I want to compile for JDK 8, it needs to concatenate the strings with string builder the old way. So, but that's basically what JavaC would do for you as well. If you set the target to 8, it cannot use the new functions. It has to stick with the old API. Are there any legal issues with using Fregal? Well, not that I would found, or not that I know, because the code is basically a forked version of JavaC, of the JDK compiler, which is licensed under GPL version 2 with class path exception. So the Fregal is also licensed with GPL with class path exception. So yeah, the licensing should be completely the same. Could we use Fregal with Spring Boot? Definitely. Well, I don't know. Spring Boot can create a Maven project, right? So then just put the snippet configuring the compiler plugin to use Fregal, and it should work. I don't see any issue. Don't you think null safe types and conditional Elvis operators are great tools, Kotlin, that are not included in Java? Yeah, well, not everything is supported in Java. Some things may appear. Actually, my Scala colleagues in Enzo, there is a lot of functional programmers there, told me that I should always use optional. So basically, optional, apply for a value, and then dot map, and dot filter, and so on, so on. So basically, even in Java, you can code like in Scala, which is functional style, and you don't need an Elvis operator. Again, as I mentioned, Kotlin contains a lot of features like this because it's like the Paysex Kočičko when they cake the cake. So those things just appear there, and actually maybe they are not even necessary because you could do it with the optional library. Okay, the main reason we are still on Java 8 is that we have strong dependencies on Java EE, Java X. Here I suppose Fregal won't help you at all. I believe Fregal would help you quite a lot. You could use all the new language features, but then, well, if you do import, you do import from Java X. It should work, I hope. What is wrong with source and target params of Java? Can it be used for compiling source code in source in 9 and source in 19 for JDK 11? Well, yeah, I think so. Yes, this is exactly it. This should be part of regular Java, but it's not. I always tried to, when I was in Oracle, I tried to argue for this being allowed, but I never got any vote on that. So I'm using Fregal because it does that and does that quite well. So we have 1 minute and a half. Let's try a few more questions. Compilation speed, that's okay. Fregal is not slower. The difference is too small. Why don't you like Scala? What about Clojure? Well, I'm starting to like Scala. But the problem is that my IDE is not really good in supporting Scala. So that's the problem. But it's getting better. I'm implementing few plugins. If I use Fregal with old JDK, does it also provide JDK 19 core libraries, new APIs? No, that's exactly what doesn't happen. The only thing that you get with Fregal is the language syntax. The libraries are taken from the target. So if your target is JDK 8, you only see APIs of JDK 8. There's not much to do about it. It has to be this way. But actually what we did in NetBeans, we tried to actually eliminate the usage of the new APIs and try somehow get rid of them. But that's for another talk and won't fit in here. So thank you for your attention, and stop by if you want to chat.